For most of human history, Saturn was the absolute end of the known world. It was a cold, slow-moving point of light drifting at the dimmest edge of the visible solar system. Ancient cultures personified this distance through Shani Dev, the Hindu god of karma and justice. He was characterized as a heavy, brooding arbiter of fate who settled cosmic debts from the furthest reaches of the sky. Early telescopic observations confirmed this sense of isolation. To astronomers in the 17th and 18th centuries, Saturn appeared as a beautiful but inert gas giant, a world permanently locked in a deep planetary freeze. This distance defined a long-held scientific rule, the Goldilocks zone. Life required a rocky planet at a warm distance from a star to maintain liquid water. But Saturn sits 1 billion miles away, where temperatures average -180 degrees Celsius. At these temperatures, chemical reactions are nearly impossible, and water is as hard as rock. For decades, the outer solar system was viewed as a biological dead end, a place too cold and too dark for anything to survive. Modern data has replaced that image of a dead world. We now see Saturn as a dynamic, hyperactive miniature solar system. In early 2026, the IAU Minor Planet Center confirmed 11 more moons, bringing Saturn's total to 285 known satellites. This massive swarm creates a complex environment. The moons and rings are in constant gravitational motion, creating a mechanical engine driven by the planet's immense mass. By studying these interactions, astrobiologists have identified at least 2 moons that appear to generate enough internal energy to support the conditions for life. This forces a reevaluation of our search for biology. If these environments can generate their own heat, scientists must look past warm stars and investigate the freezing, dark depths of the outer solar system. In 2004, the Cassini mission reached Enceladus. It is the most reflective body in our solar system, appearing as a sphere of pristine white ice. Cassini detected massive geysers of water vapor, salts, and organic molecules jetting hundreds of miles into space from the moon's southern pole. These geysers are powered by tidal heating. As Enceladus orbits, Saturn's immense gravity physically stretches and deforms the moon's rocky core, creating friction and heat deep in the interior. This friction melts the ice from the inside out. It sustains a global liquid water ocean hidden miles beneath the frozen surface. At the bottom of this dark ocean, hydrothermal vents release hot, mineral-rich water. These vents provide the energy and the chemical building blocks necessary to support biological processes without a single ray of sunlight. The pressure in this ocean is so high that the water blasts through fissures in the ice, supplying the material that forms Saturn's E-ring. Enceladus proves that life-supporting heat can be generated by gravity alone. It confirms that biospheres can exist in total darkness, independent of a host star. Saturn's largest moon, Titan, presents a different environment. It is the only moon in our solar system with a thick, nitrogen-rich atmosphere, similar to the skies of early Earth. In 2005, the Huygens probe descended through Titan's orange haze to find a landscape shaped by flowing liquids, featuring rounded river rocks and carved drainage networks. On Titan, it is too cold for liquid water. Instead, liquid methane and ethane take its place, flowing through riverbeds and pooling in vast seas. Titan has a complete weather cycle. Methane clouds produce methane rain, which feeds hydrocarbon seas larger than any oil and gas reserves on Earth. This makes Titan a massive laboratory for prebiotic chemistry. It forces us to consider if alien life could use methane as a solvent, thriving in conditions once thought too hostile to even consider. In 2017, the Cassini mission came to an end. After 13 years at Saturn, the probe had exhausted the fuel it used to maintain its orbit. To prevent the mission from ending in an uncontrolled drift, NASA programmed Cassini to plunge directly into Saturn's atmosphere to be vaporized. This deliberate destruction was a matter of planetary protection. NASA had to ensure that no microbes from Earth, still clinging to the probe, could crash into and contaminate the habitable oceans of Titan or Enceladus. The decision to vaporize a billion-dollar spacecraft demonstrates the weight of the data it collected. These moons are now treated as pristine environments where life is a distinct probability. NASA is preparing to return to these worlds,
In 2034, a new mission called Dragonfly is scheduled to land on the surface of Titan. Developed by the Johns Hopkins Applied Physics Laboratory, Dragonfly is a car-sized, nuclear-powered drone designed to fly through the moon's atmosphere. Titan is an ideal place for flight. It has only 14% of Earth's gravity, but 4 times the atmospheric density. This specific combination provides a massive aerodynamic advantage for our rotorcraft. Dragonfly will perform vertical takeoffs and landings, hopping miles at a time between diverse regions like the Shangri-La dune fields and the Selk impact crater. It will use a suite of mass spectrometers to sample Titan's chemistry. The goal is to identify biosignatures in areas where liquid water and complex organic compounds have interacted. These missions have provided a new template for where life might exist. It suggests that biology doesn't necessarily need a warm sun. It only needs a source of energy, even if that energy is hidden deep beneath the ice.